Good morning. I welcome all the students to Pune College of Arts, Science and Commerce Camp Pune 1. I teach Statistics General to SYBA class. Myself, I am Professor M.B. Pathan. In last lecture, we have discussed about determination of sample size. If sample is drawn by simple random sampling with replacement or by simple random sampling without replacement. Before starting a survey, it is necessary to decide how much units should be drawn from the entire population in order to get appropriate estimation of population mean, in other words, population total, with given certain margin of error. So we derived the formula of small n, that is a sample size, under with replacement and without replacement for both type of characteristics. That means if you are studying a variable characteristics, what will be the sample size? And if you are studying qualitative characteristics, that means attribute called as sampling with proportions, what will be the sample size? Today we'll try to open a new chapter under the heading of stratified sampling, stratified random sampling. We finished before simple random sampling of two types, with replacement and without replacement. Let us see what is the difference between stratified random sampling and simple random sampling. An important objective in any estimation problem is to obtain an estimator of population parameter which can take care of the silent features of the population. That means whenever you are studying estimation problem, we have to worry about the proper estimation. We have to worry about proper estimation about the population quantity. If the population is homogeneous with respect to characteristics under study, then simple random sampling will provide a homogeneous sample, and in turn to that it gives good estimation of population mean. That means SRS, simple random sampling, perform better way under the condition. That condition is population under study should be homogeneous. The meaning of homogeneous: almost each and every unit of the population will have equal response, uniform response to the respective characteristic under study. There will be small variation in the response from one unit to another unit. That type of population is treated as a homogeneous. So we prefer simple random sampling if the population is homogeneous. Thus, if the population is homogeneous with respect to the characteristic under study, then simple random sampling is providing good estimate for the population characteristics. But in the other case, if the population is not homogeneous, that means there is a heterogeneity, then simple random sampling will not provide good estimate of population quantities. So in such situation, we try to apply stratified sampling. So I think you understand when we go for stratified sampling. We apply stratified random sampling under the assumption that population under study is heterogeneous. The basic idea behind the stratified sampling is divide the heterogeneous population into small groups, or you can call as a subpopulations, such that sampling units will be homogeneous with respect to the characteristic under study within the subpopulation, and it will be heterogeneous with respect to the characteristic under study between the subpopulation. Such subpopulations are termed as a strata, and after getting a strata, we treat each and every subpopulation as a separate population, and for every strata we apply previous technique of drawing a sample, that is simple random sampling without replacement. I repeat again, in case of stratified random sampling, our basic assumption is population under study is heterogeneous. So to apply stratified random sampling, the first step is to divide heterogeneous population in different subgroups. Suppose I divide total heterogeneous population into K groups. What is the method of division? Every subgroup, that is a strata, should be homogeneous within. And if I compare strata 1 with strata 2 or strata 3 and so on, so strata 1 should be heterogeneous as compared to others. Similarly, strata 2 should be homogeneous within but should be heterogeneous between. That is the way of making subdivision of heterogeneous population. Once you divide heterogeneous population to homogeneous groups, then again we go by previous chapters, simple random sampling without replacement. Under stratified random sampling, with replace method is not allowed. We use only simple random sampling without replacement. So I can say you are not studying a new topic, you are studying again what I taught in previous chapter. But to apply previous chapter, at the initial stage, you have to make classification of heterogeneous population to homogeneous strata. And then you go by same methods. For every strata, apply simple random sampling without replacement and get the sample. Example to understand this, in order to find the average height of students in a school of class 1 to 12, the height varies a lot, as the student in class 1 are of age around 6 years and student in a class 10 are of age around 16 years. So one can divide all the students into different subpopulations or strata such that I will call student of class 1, 2 and 3 as strata 1. Student 4, 5, 6 as strata 2. Student 7, 8, 9 as strata 3. Student from the class 10, 11, 12 as strata 4. So we'll be having 4 subpopulations for this example. If you recall your previous chapter, this problem will be studied for entire students running from standard 1 to 12 as one population. And from all these 1 to 12 class students, we pick up one sample. And then with the help of that sample, we try to estimate height of the student. Quite natural. If you take a student from first standard to 12, the variation in the height as a characteristic under study is very large. So such population become a heterogeneous population. So there is a large variation. Our first task in the statistic is try to minimize the variation as far as possible. So we can minimize this variation by dividing heterogeneous population into small part labeled as subpopulation or strata. And after that, suppose I want to study only 100 students from this standard 1 to 12. So what I will do, I will pick up some student from strata 1, then I will pick up some student from strata 2, strata 3 and strata 4. That means subpopulation 1, subpopulation 2, subpopulation 3 and subpopulation 4. The advantage of this is every student will represent in your sample. That may not happen in the original study of all 1 to 12 students. And that is why stratification, this division of the population into strata, is known as a stratification. So stratification gives better estimate as compared to the simple random sampling, which is applied to the original population. Now draw the samples by simple random sampling without replacement from each strata. So all the drawn samples combined together will constitute the final stratified sample for future analysis. I think you understand the concept of stratified random sampling. Again, I repeat, you can divide the heterogeneous population into different groups. Then from every group, draw the separate samples by without replacement. Then combine all these samples together and use this sample for your estimation. The biggest advantage of stratified random sampling is it represents each and every corner of the original population. To study stratified random sampling, we require some notations. Let us see what are the notations for stratified random sampling. Capital N stand for complete population size. K indicate number of strata, number of subpopulations, number of subgroups. Capital Ni subscript, number of sampling units in ith strata. I think this word should not be there. You just scratch it from the notes. Number of units in ith strata, capital Ni. Sampling word should not be there. Capital N is sum of all population strata size, N1 plus N2 plus dash dash Nk. We divide original population into K groups. Parallel to capital Ni, there is a small ni. Parallel to capital N, there is a small n. Small ni indicate number of sampling unit drawn from ith strata by using without replacement. That means in this example, you pick up N1 student from strata 1, N2 student from strata 2, N3 student from strata 3, N4 student from strata 4. Then you combine all these students, you get stratified random sample. Summation of small ni, I1 to k. That is a total sample size. For better understanding, I have a tree diagram for stratify random sampling. On the top, we have heterogeneous population of size capital N. First step, divide heterogeneous population in different stratum called as a strata. Strata is a plural form, stratum is a singular form. Stratum 1, strata 1 you can say contain N1 unit. Strata 2 contains N2 unit. Strata number K contains Nk units. N1 plus N2 dash dash Nk gives capital N. After making this division, from every strata, this arrow says pick up a sample of size N1 by the method of without replacement. From second strata, draw the sample of size N2. Similarly, from the last strata, draw the sample of size Nk. Now, this is separate samples, which is by without replacement. Here, you can apply without simple random sampling. Because what is the nature of strata 1? Strata 1 is a homogeneous. So you can study this strata by previous chapter. This is also homogeneous. So you can study this by using previous chapter, that is simple random sampling without replacement. If I compare strata 1 with strata 2, they are different. So within strata, it is homogeneous. Between the strata, they are heterogeneous. So within is nothing but simple random sampling method. Between is not allowed. So small n is n1 plus n2 plus dash dash plus nk. It is the combination of all these subsamples. What you get by making all combined together is named as stratified random sample of size small n. Try to understand how the work procedure for stratified sampling. Divide the population of capital N units into K strata. Let ith strata has Ni units, I1 to K. Strata are constructed such that they are non-overlapping and homogeneous within respect to the characteristic under study. Total of stratum size is original population size. After this, draw a sample size Ni from ith strata using simple random sampling without replacement. All the sample unit drawn from each strata will provide a stratified random sample of size small n. So you can write procedure of stratify random sampling by this way. Better way after this explained by tree diagram. Firstly write description and then draw the tree diagram to more elaborate clearly. Now difference between stratified and cluster sampling scheme. Cluster sampling we are going to study after this at the end of the chapter. At that time we will try to make a difference. Issue in the estimation of parameter in stratified sampling. That means how to make a estimation of population quantity by using stratified sampling. Divide the population of capital N units into K strata. Let ith stratum has Ni units 1 to K. Note that there are K independent samples drawn through simple random sampling without replacement. Write clearly SRSWOR. We get N1 from capital N1, N2 from capital N2, and so on. So one can have the estimate of parameter based on the sample size N1, N2, Nk respectively by using simple random sampling without replacement. Our interest is not to have K different estimate of the parameters, but the ultimate goal is to have a single estimator. You can study only N1 and get the estimate of population. But that will not be better for capital N, it will be better for capital N1. By using N2, you can decide an estimate for entire population, but it will not be adequate, consistent for total population. It will be consistent only for capital N2 because this is a sample by without replacement from capital N2, which is a homogeneous. So from previous chapter, this gives estimate of subgroups, not entire population. In this case, an important issue that is have to combine the different sample information together into one estimator, which is good enough to provide the information about the parameter of the population. Parameter is a constant quantity related to the population, be remembered. We now consider the estimation of population mean and population variance under stratified sampling method. Notations for getting a estimation. Let capital Y is a characteristic you can call variable under study. The example just now I told about the height of the students. So capital Y stand for height of the students under study. Yiz, capital Yiz, it is a value of zth unit in ith stratum. So if you take an example of that students, all the students divide into 4 strata. So if I say Y11, what you will the interpretation? It is height of student from first strata with first student. What is Y12? Height of the student from first strata, second number student. So this is nothing but your notation for indicating value of the unit from the population. If I call this as a small yij, j will be 1 to small ni. If I call this as a capital yij, j will be 1 to capital Ni. Very small changes in the notation of population and sample. Y bar I dot. I forgot to write dot here. It is 1 upon capital Ni summation Yij J1 to Ni. Now when I put a capital letter, that means I am speaking for population mean of ith strata. Now here I replace small yi bar, so it is a sample quantity. So respect to this, we have a sample quantity like this, sample mean from ith strata. This is calculated for Ni values capital. This is calculated for small ni values drawn from capital Ni. So the sample mean for ith strata, population mean of ith strata. Capital Y bar, it is a population mean. 1 upon capital N, summation I1 to K, Ni multiply Y bar I dot. This dot is for second subscript. Ni divided by capital Ni labeled as a Wi, you can call it as a weightage. Weightage given to the mean of ith strata, I1 to K. So this is a formula for population mean, where Wi taken as Ni upon capital N, you may call as a proportion, or you can write Y bar summation I1 to K J1 to Ni Yij. How this formula comes? It is coming from Yi dot bar, which is written here. So this Ni goes on the left side, that is nothing but your double summation I1 to K capital N. So this quantity is a total of all population values divided by total number of units in entire population. That is Y bar. Estimation of population mean under stratified random sampling. First, we discuss the estimation of population mean. Then we go ahead. Note that population mean is defined as the weighted arithmetic mean of stratum means in the case of stratified random samples, where the weights are provided in terms of stratum size. I told just now Wi is Ni upon N. So weightage proportional to the stratum size. Based on the expression Y bar 1 upon capital N I1 to K Ni multiply Y bar I, may choose the sample mean. This is the sample mean overall 1 upon small n summation I1 to K Ni small multiply Y bar I dot small. As a possible estimator of capital Y bar, since the sample in each stratum is drawn by without replacement, by using previous chapter, we proved expected value of sample mean by without replacement is a population mean. There is no hurdle to write like this because every strata is homogeneous. So for every strata you can apply previous chapter results. So this is true with the help of previous chapter. Thus, expected value of y bar, the formula is here, equal 1 upon n summation I1 to k ni expected value of y bar I. Y bar I is a sample mean by without replacement from homogeneous population. So expected value of sample mean is a population mean. Here population is particular strata. Capital Y bar I dot. Now if you look this is not giving answer as a capital Y bar, because capital Y bar formula is summation I1 to k ni y bar I dot by capital N. This is your population mean, or this is you can take population mean. Both are true. So to overcome this difficulty, we make some adjustment. And y bar turns out to be a bias estimator because it is not equal. Based on this, one can modify sample mean so as to obtain unbiased estimator of population mean. So if you use this as a formula of estimator which is not unbiased, it comes biased. We modify our formula of estimator as below, called as y bar estimator of population with stratified random sampling. 1 upon capital N summation I1 to k capital Ni into small y bar I. Remember, capital Ni and capital N, these are the population quantity which many often known in advance. Size is known. Values are unknown of the variable. Ni upon capital N is Wi. Now you take the expectation of this left side. Expected value of y bar st is 1 upon n summation I1 to k ni time expected value of y bar I. And when I speak for this as a particular study, it is the study of homogeneous population. So from previous chapter, easily you can write this as capital Y bar I. Now summation Ni capital Y bar I divided by capital N is nothing but by formula of your capital Y bar. So Y bar St is treated as unbiased estimate of population mean under stratified random sample. Thus, Y bar St is an unbiased estimator of population mean under stratified random sampling. Now, what will be the variance of your estimator? So we try to develop the variance. Variance of Y bar St equal to summation I1 to k Wi square variance of y bar I plus double summation I not equal to j Wi Wj into covariance term. Since all the samples have been drawn independently from each of the strata, so covariance term this is to be written at this place. This is not come in the scan copy. This covariance YIYZ, it comes 0 because we draw samples from every strata independently. So mean of ith strata, mean of jth strata totally independent. Hence, by your first year result, if x and y are independent, covariance is 0. So this product term is cancelled. So what I get? I get variance of y bar st summation wi square variance of y bar I dot. Now this is known to you because this is a sample drawn by without replacement from ith strata, which is a homogeneous. So you can apply the result directly for ith strata. So variance of y bar I dot equal ni minus n I divided by ni into ni si square. Look here, this is the formula from previous chapter. Variance of y bar n minus n divided by n into n s square. This is for entire population of size capital N with sample size small n. Now I am not speaking for entire population, I speak only for one of the strata. So n replaced by ni, small n replaced by small ni, s square replaced by si square. It is just like parallel, where si square is again similar 1 upon ni minus 1 summation j1 to ni yij minus y bar I dot whole square. Therefore, I get variance of y bar st summation I1 to k wi square, and this is the variance of y bar ni. We can simplify this a little bit. Take small ni separately. Capital Ni minus small ni divided by capital Ni is like this. Observe that variance of y bar st, estimate of population mean under stratified random sampling, is small when Si square is small. So variance of y bar st directly proportional to variation of ith strata. So if your strata is more homogeneous, corresponding variance will be smaller. If stratum elements are more heterogeneous, then variance will be large, and vice versa. These observations suggest to construct the strata. So we have to construct strata as far as homogeneous within and heterogeneous between. If Si square is small to all I1 to k, then variance of y bar st is also small. That is why it was mentioned earlier that strata are to be constructed such that they are within homogeneous. That is, Si square is small and between they are heterogeneous.